Hey y'all, today we're going to stick with our probability stuff and we're going to talk about random variables. So we use the capital letter X when we're talking about a random variable. And a random variable, sort of a technical definition, can assume any of several different numeric values as a result of some random event. So I wrote a discrete amount. Right now we're going to talk about discrete random variables. That means there is a limited number of possibilities. And so this tends to make a little more sense when we put some context to it. So we have an insurance company and they sell insurance policies for $50 a year that pays out $10,000 when you die and $5,000 when you're permanently disabled. And so this is a random variable because we know the possible outcomes, but we don't know what exactly is going to happen. There are three possible outcomes. You could die, you can get permanently disabled, or neither of those things could happen. And so we want to explore to see if this company can make a profit. So we can create a probability distribution. There's three different possibilities here for this random variable: death, disability, or neither. These are the possibilities numerically: $10,000 for death, $5,000 disability, $0 for neither. And then they have uh, these probabilities from previous data that 1 in 1,000 people who have this plan die, 2 in 1,000 people get permanently disabled, and then the remainder have neither of those things happen. So to further explore that insurance company to see if it's worth their time and money, we need to talk about what an expected value is. So expected value can be written these two ways: E of X or mu, because they are kind of like means. And it's a value that we can expect in the long run. So here's a formula for the expected value. We take all of the x's like we had on the previous page, multiply them by their probability, and then add all of those things together. This symbol, for those of you who don't know, means to sum, which means to add, of course. So we want to know the average payout for policyholders, the expected amount that the insurance company is going to owe each policyholder. So we take the $10,000 for death and multiply it by its probability, 0.001, 1 in 1,000. Add to that $5,000 times its probability, 2 in 1,000. And add to that $0 for the people who stay alive and healthy by its probability. So what we end up with is $20. So we can expect to pay out an average of $20 per policyholder. So I said on the previous slide that they charge $50 a year for this insurance policy, and they're expecting $20 per policy they sell for a payout, so that makes them $30 per policy every year for this insurance policy. So obviously, everybody who buys an insurance policy is not going to get $20 back. It's just an expected amount per policy. It's an average amount. There's going to be some uh, variability here. Some people are going to get paid out, and some people are going to be fine, healthy, and alive, and they're not going to get paid anything. So we need to examine the standard deviation. In order to do that, we should find the variance. So from earlier this year, this Greek symbol sigma stands for standard deviation. Sigma squared is standard deviation squared, which is just the variance. So to find variance, we do each value for the random variable, subtract the mean, square it, and multiply it by its probability. And then we add all those together, and when we get that, we can square root the variance to get the standard deviation. So again, let's just do one of those so that it makes a little more sense. So we want to know the standard deviation of the payouts for this insurance company. So we'll add another column, the deviation column. So we're going to take our payout and subtract the mean. Our mean we found was $20, so we're just doing 10,000 minus $20, 5,000 minus $20, and 0 minus $20. And so now we have all these x minus mu's that we can put into this formula. So we take our 9,980 squared, multiply by its probability, 1 in 1,000. 4,980 squared times its probability, 2 in 1,000, and so on. And we end up with this value for sigma squared, or the variance of the random variable x, as $149,600. What we really want to know is standard deviation. So we're going to take this value and we're going to square root it and find that the standard deviation for payouts for this insurance policy is $386.78. So one standard deviation is $386.78. So again, our expected value is about $20 per person payout, but that's not always going to happen. Some people are going to actually need the 10,000 payout or the 5,000, and some people are not going to need it at all. So the expected value is $20 with the $386.78 standard deviation. So we want to do one more full example together before I'll leave you to it. This is on page 391. Do not write this down. You could go to 391 if you want to take a look at it, or you can just pause a second and read the scenario here. So here we have a restaurant that's offering a special Valentine's Day deal. You pull the ace of hearts and you get a $20 discount. You pull a black, I'm sorry, an ace. Oh, I'm sorry. You pull a black ace and you get no discount. You pull the ace of diamonds and you get to pull one more time. And if you get the ace of hearts on the second turn, you get a $10 discount. So let's create a probability distribution here. Here's our values: 20 for an ace of hearts, $10 for an ace of diamonds, then an ace of hearts, and $0 for a black ace. So 25% chance of getting the ace of hearts the first time, getting an ace of diamonds and getting an ace of hearts. That's a multiplication probability. Notice that the probability changes here. It's a 1 in 4 chance of getting the ace of diamonds, and then it's a 1 in 3 chance of getting the ace of hearts, which gives us a 1 in 12 chance of getting this discount. And then 1 minus 1/4 plus 1/12 gives us whatever's left over. That's the probability of getting a black ace. And that, you would think it would be 0.5, but you can get a black ace right away, or you could get a black ace after you've drawn the ace of diamonds. So we have to be careful there. So we can use our expected value formula to figure out what is the expected discount per couple. So we multiply each discount possibility times its probability and add them all together and get $5.83. So we should expect to discount $5.83 per couple who eats there. Now, of course, not everybody's going to get a discount. Some people are going to get $20, some people are going to get $10, and some people are going to get 0 discount. So we could find also the standard deviation by adding that deviation column. So we just take the $20 minus the $5.83, $10 minus $5.83, and then of course 0 minus $5.83. And we can use these values to find variance. And then to get standard deviation, we will square root the variance and see that our discount varies $8.62. So we have an average discount of $5.83 with a standard deviation of $8.62. So that's all we have for today. We'll do some problems together in class. Make sure if you have questions you ask, and I'll see you soon.